Welcome to Pipeflow Software. This video provides an introduction to our Pipeflow Expert program, which is our premier software for modeling and solving pipe networks to find the steady state condition that balances the flows and pressures within the pipe system. This is the Pipeflow Expert interface. It has a number of general areas. This is the drawing area where we draw the system. Above the drawing area is the drawing items menu, which we use to select and drop items onto the drawing grid. To the left hand side we have two panels. One is the node panel, which shows the details about particular points in the system, and the pipe panel will give us details about particular pipes in the system. Let's go ahead and load an example system so we can see what a drawing looks like. If we select the file menu and we choose Open Examples, and here we have 16 examples that the user can scroll through and choose one to load. When we load the example is shown on our screen, and we can zoom in or out by scrolling the mouse wheel. We can click on an item such as the supply tank, and the details of the tank are shown in the node panel. This gives the surface pressure, the liquid level, and the bottom elevation of the tank. We can click on a pipe to highlight that particular pipe, and we can then review the details of the pipe here, which is 15 meters of length, the internal diameter 57 millimeters. It will show us the roughness of the pipe, saying it's stainless steel, Schedule 5S. We can also click on these tool button items to update or to move various items on the drawing. If I click on the pan tool, we can drag the drawing or move it to a different position on the screen. If I click on the move tool, all the nodes become highlighted, and we can just drag a node and drop it at a different position. Or we can move it back to its original position, and all the text labels and all the information on the drawing automatically up and moves with the node. We can also draw and add additional pipes. We can click on a tank, for example, and then we can start to draw additional pipes around the system. We can click Undo to remove the pipes that we've added, and we could similarly add new tanks, or we could add additional pumps, etc. to the drawing. Let's go ahead and solve this system so we can see the type of results that are produced. We click on the Calculate button to solve the system, and this is the results log, which tells us that the network was solved successfully, and the solution values are displayed on the drawing in the background. We can review the log, and we can see that the solution was found very quickly. If we scroll down the log, we can find some information that tells us the Darcy-Weisbach method was used to solve the system, and it gives us various information about the accuracy of the pressure balances, the friction losses, component losses in the system, and the total pump head that was added within the system. No issues to report. We are now asked, do we wish to view the detailed results table? If we say yes, the results of this system are shown in a spreadsheet-like grid, and this is the Pipes tab. We can see all the pipe details, the flow in each of the pipes, so meters cubed per minute, the velocity of the liquid in each of the pipes, and if we scroll across, we can see additional information such as the friction factors, the friction loss in each of the pipes, the fitting loss, component losses, etc. We can also click on the Nodes tab, and this will give us information about each of the points in the system, including the pressure at each node within the system. If we go back to the Pipes tab, we will see pipes are coloured, the pipe ID is coloured, and on the results screen there is a colour gradient that details the flow rate in each of the pipes, and this gradient can be amended to show friction loss or total pressure loss in a pipe, and so it becomes very easy to visually through the colours to see which items in the system where the highest flow is or where the highest pressure loss is. If I close the results grid, we're still in results mode, and by hovering over a particular pipe we can see in the yellow bar at the top of the window the details of that pipe. For example, it shows pipe 8, the pressure drop of 0.23 bar and the flow rate of 0.146 meters cubed per minute and a velocity of 1.533 meters per second in that particular pipe. We can also hover over the pump and we can see the suction pressure, the total head and the MPSH available for the pump. So we have quite a lot of information on our results screen, and this can also be changed to show in different units. If we click on the Units tab, we could switch all these units to imperial, or we could actually choose individual units for length, diameter, roughness, head losses, flow rate. If we select imperial, we can see all these units have changed, and if we say OK, we're still in results mode, but all the values have changed and we are now showing those results in imperial units, such as, for example, velocity in feet per second. So this is a good indication of the flexibility of this software and an introduction to one of our example systems, solving that system and looking at some of the data within it. We have further videos that you can review which demonstrate other features within the PipeFlow Expert software.